So here's a different way to approach this problem and how the facility of these tools can really help with that. So just bear with me on this. I'm going to take this square and I'm going to move it here. And what I'm going to do is I'm going to make this a little more transparent so you can see through it. And I'm just going to ask you real quickly, my friends, what's the area of that square? So go ahead real quickly and tell me, what do you think the area, what is the area of the square? Okay, what is the area of this square? Just go ahead and input that for me. Okay, so 5, 4, 3, 2, and 1. And let's see what you came up with. And I can see here that you said 9. Okay, you said 9. All right. Why did you say 9? Ideas. Okay, so you said 3 by 3, so you noticed that there was some type of array here, a 3 by 3 array. Okay, what else? How would you know it's 9?
9, there are 9 each square.
Perfect, right? You just counted the squares. And you notice here that this is 1 square unit. You counted the squares, got it. Perfect. Any other way that you know it's 9? What did you do with your 3 by 3? How did you come up with 9? How did you come up with 9? You said 3 by 3. What did you do?
Lado por lado.
Okay, so you multiplied, right?
Yeah.
So she has a generalization in her head, right? Like a formula kind of thing. Okay. So at this point, I would say to you, all of you are correct. The answer is 9, and it's because of all the reasons you said, okay? But what I'm going to do is I'm going to take this away, and I'm going to bring this here, and I'm going to ask you, what do you think the area of that triangle is? Okay? And at this point, students, if they don't remember, right, will look at you and say, I don't think I know. And this is a really wonderful moment because now what you can do is we can activate what you just told me. So I'm going to do this. I'm going to bring this square here. You told me this was 9. If I bring this triangle and I put it over the square, what do you notice? It's half. So if this is 9, what do you think this is?
Half of 9.
Half of 9, which is? 4.5, right? And you said, young lady in the back, that to find 9, right, you said length times width. Lado por lado, right?
Yes.
What do you think it is for this? Yeah, so just in a span of a few seconds, you just conjectured the formula for a triangle, okay? And I guarantee you won't forget that. You won't forget it because you've made connections here. And you can make bigger connections because I can move this around and I can say, what if you take this? This is called a parallelogram, okay? What is the area of that shape? Well, kids, they're gonna model or they're gonna regurgitate what you do, right? So they're gonna say, well, what if we do the same thing? Can we do the same thing? Look at there, we can, right? And now I can ask you, is there a connection with these two shapes? Are they the same? Do they have the same area? Why? Okay? And I can say, you know, these are what we call simple shapes. What if I make this more complex? So with a click of a button here, I can change the shape so it looks something like this. Do you think you could find the area of that? Probably, right? Yeah. Because you can figure out that, oh, I have a square and then I have a triangle. I have two things now. And so what's happening in here is you're scaffolding content, right? Little by little, you're chunking content so they're able to understand it. All right, at this point, this is what happens, as you well know. You just did all this, all of you are like eager, right? You know all the answers. And I say to you, do you understand? And what do you all say? Yes, I do, right? But I still don't know whether you understand or not. So there's another wonderful facility of these devices that I'd like to share with you real quick. In my class, we used to do something called a blitz, and it only took 2 minutes of class time. That's all it takes, right? But really, it was for me to understand whether or not every single one of my students understood what we just did. And if they didn't, then I can target that student right away, instead of waiting until the end of the class, or maybe waiting until they're more frustrated with the content. So this is what I'm going to do. Right now, up to this point I should say, I've been asking you questions, where I put the question here, and all of you answer the same question at the same time. I'm going to reverse that now. I'm going to send the question to you, and then you answer it at your own pace, however you feel comfortable. Make sense? There's 6 questions total, and there's 3 levels. There's 2 questions per level. If you get 1 out of the 2 questions right, it bumps you to the next level. Make sense? All right? If it says in the question, figure A is such and such, this is what it means. This is figure A, B, C, and D. Okay? So let's see if we can start this real quick. So if you look at your device, it's asking you a question. You may or may not have the same question as the person next to you. That's okay. Try to go through these questions and answer them as best you can. Okay, what I'm going to do is I'm going to pause this, because I'm going to show you something. Okay, let me show you how to read this graph. So here I have student A. Okay? Incidentally, these are anonymous, but I could have the students' names on there if I wanted to. Okay? You can choose to do that. I noticed that this student got done really, really quickly, as opposed to maybe some other student that was taking a little bit longer. Okay? So as a teacher, I know several things. The color tells me what level you're on. The length of the bar tells me how long you were on a particular question. And if I hover over here, it tells me what the question was and what you answered. If you got it wrong, like here, it tells me what the answer is, what the student answered, and what the answer was correctly, right? What the answer should have been. And I noticed here that they didn't get it wrong, they just misspelled it, okay? So these are really good targets. Now, as a teacher, this is invaluable. Because if I know that a student is getting it wrong and wrong and wrong, right? Then I can automatically target that student and intervene and ask that student, where is it that you're going wrong? If I didn't have this facility, I would never know. Because students, right, mostly are not going to say, I don't understand. They're just going to kind of keep quiet because there's a social thing going on. They're embarrassed or they don't want those things to happen. They don't want anybody to know. And so this is a really invaluable tool to be able to determine whether or not all of my students are meeting the targets that I want them to meet. Okay, so that's an example of how we can do the feedback. The other question we get a lot as math teachers is, who cares? Why do I need to know this? Who cares, right? When am I ever going to use this? Have you heard that before? Okay. Right? So we just did something on area. Here's a particular topic that we could do, okay? Suppose that I say to them, we're looking at a map, and I want to find the area of this region. Can I do that? Well, using what we know, I can fill this with the shapes that we just learned, right? And as I fill these with shapes, I can also turn on a grid that's aligned to the scale down here. And then I can figure out what these values are. And I can find an estimation, okay, my estimation here, and see if my estimation is the same as the actual value. So now we're targeting not just area, we're targeting concept of estimation. Okay, so we're combining multiple things within the context of something that they will encounter or something that they see every day. So they find use for the mathematics. Now, that's really important when we talk about use, because here's another way in which we can really target students with these tools. Do you remember how you were taught how to add? Do you remember this? How do I add 12 plus 8? What do I do first?
8.
2 plus 8.
Yeah, I add 8 plus 2, and I get, what do I get? 10. Do I write it like that? No, what do I do?
First 0 and then...
You can tell me in Spanish if you like.
Pardon me?
You can tell me in Spanish if you like,
Okay.
if that's easier.
Primero 0, debajo, y luego se le suma el 1,
Okay.
the 1 there, and then you sum up 1 plus 1, and then you have 2.
Okay. And why do we do that? Why do we do that?
Because you have to see it to know if it is there.
Okay, we have to see. All right. I propose to you that when you teach this to a little kid, it's hard because it's abstract. It doesn't mean anything, right? It's just a series of steps that you're telling them to memorize. They have no conception of why this matters, right? Until you represent it in a different way, okay? So one of those things that in that list that I showed you was representation of content. So here's the representation of 12 plus 8. I have a block of 10, 2 singles, make 12. No 10s, 8 singles, make 8. Make sense? All I want to do here is make blocks of 10. Now incidentally, do you know why it's blocks of 10? Why not blocks of 12?
Why?
Anybody know?
Una decena.
Say again?
Es una decena.
Yeah. Yeah, units, right? Our system is based on tens. That's why we do tens. And that's something that typically we often overlook when we're teaching this to students, but it's really important for them to know. So what I can do here is I can take these little guys and I can make 10 out of it, just like this. So there's 8 and there's 2, that makes 10. I'm going to group these together, bring this over here to the tens column. How many 10s do I have?
2.
2, which makes?
20.
And how many singles do I have? None. So this needs to be 20. I propose that if you do it this way first, it's a lot easier for them to understand this second, as opposed to making it backwards. Okay, so here's another example. As you can see, a more complicated example, but it's the same thing. Okay, make 10 here. So here we have 7. Okay, to make 10, we need 2 more, right? No, 3 more. And then we group these together. How many 10s do I have? 4 of them, which makes 40. How many singles do I have? 2, which makes 42. And when you add this together, you get 42. Okay, same idea.
If you want to put 11,
Yes, ma'am.
can you put 11 in the same?
You can if you like. Absolutely. Yeah, you can change that any which way you want. One of the greatest advantages of doing this is that as students are working, other students are watching and assessing what they do. And if it is wrong, most often kids will say, wait, that's not right, which is what you want because they're actively thinking about the content that's going on the board. Okay? Now, so far, and by the way, we can do this with all sorts of things. We can do division. If you're looking at factoring, you can do factoring as well. Okay? So here we have a problem here. This is x squared, okay? And we have 7x and 6x, this is x. So we have 6 of these, 3, 4, 5, 6. And then we have, let's see, 1, 2, 3, 4, 5, 6, 7. One more, right? And then we have 6 of these. And the whole goal when you factor, you have to make a rectangle. That's the whole goal. So when you work it all out, this is what it looks like. Okay? And so you can see here that this is the answer you arrive. So it's a different way to look at mathematics. Okay? That makes more sense to students because they're more visual today. All right. Now, we've been doing a lot of stuff where we do stuff up here. But there's another component, which is how do I get kids to do things on their own, right? How do they learn the mathematics on their own? So do you guys remember this when you were taught how to work with a compass? Remember that? Okay. So here's a line, and if I wanted to cut this line in half, right? I would say, okay, students, you're going to draw this line here, and then you're going to reflect this, right? And you're going to draw this line here, and then you're going to connect the dots here, right, with your ruler. Remember that? Remember how to do that? This is something, again, the kids are looking at this and they're saying, this is a waste of time. Why do I ever need to know this, right? Okay. Well, one of the things that we can do is propose problems to them that mean something to them again. And here's a problem I propose to you. So here's a map of the city, okay? And I can say to them, suppose 3 of us are out and about on the city, and we want to meet for lunch, okay? You're here, I'm here, and our other friend is here. Where is the best place to meet so that we don't all have to walk, so it's fair, right? Okay, so it's fair. So what we're going to do, my friends, is we're going to use that skill, but we're going to put it in context, okay? And so if I make this transparent, this is the mathematics, right? But when we take all that mathematics out, we come up with a point. And when you look at that point, kids are going to say to themselves, does that make sense? Is this point equidistant from all 3 of us, right? And so you get them thinking, which is what you want. And you realize that maybe that's not the best way to do it. Maybe it's this construction, which is a different construction, right? Which now, if I take the math away, I can see now that if we meet in this little area here, then that would be the best place to meet, right? And by the way, this is how your phone works. Your GPS, triangulation. That's what that is, okay? So now all of a sudden, you're putting all these concepts together and making it more meaningful for them, okay? All right, so with that, I'm going to show you two more things before we end that I think are going to go into this concept of working together.